This video is about finding rates from a table and graph. So we have a pool is being drained at the end of the summer. The following table represents some data from the situation. So we have our hours elapsed and it goes 2, 4, 6, 8. And we have the volume of water in the pool in gallons. So we have 1200, 900, 600, 300, and 0. What is the volume of the pool when the pool is starting to be drained? So the pool is starting to be drained at 0 hours. So at that time, it is going to have 1200 or 1,200 gallons. How long did it take for the pool to drain? So the pool is drained when there is 0 volume left, and 0 happened at 8 hours. How do we know the pool is being drained based on the table? Well, we know the pool is being drained because the volume is decreasing over time. Number 4, determine your rate of the pool situation by doing your jumps in the table. So if we go up to our table and we look at volume, each of these numbers is changing by minus 300 for our jumps on the Y side, and on the X side with the time, all of our hours are increasing by 2 hours. So to find our rate, we would have negative 300 over 2. That reduces to negative 150. For our units, the change in the 300 is by gallons, and the hours, and 2 is the hours. So when we reduce, it'd be 150 gallons per hour. Is your rate consistent? How can you tell? Yes, because we have the same slope throughout. What is the context? What does the rate mean in the context of the problem? It means the pool is being drained at a rate of negative 150 gallons per hour. Does a negative rate of change make sense for this? Yes, because to drain a pool, you need to remove water. So because we have a negative rate of change when we are draining the pool, if we had a positive rate of change, we would be filling the pool. So up to this point, we have talked about rate of change and starting point. Rate of change refers to how a function is changing and the steepness of a line. Slope is another name for rate of change. The starting point of a function is the value that represents the point on the graph where the function starts. The starting point is also known as our y-intercept. So the y-intercept is the ordered pair where our graph hits the y-axis. This represents the starting cost or amount in our function. It always begins with 0, comma, a number. So our y-intercept is always going to be the number by itself. For slope, in a graph, we do our rise over run. In a table, we use our jumps. It is the measurement of the steepness of a line, and it is attached to our x in the function rule. So let's fill in our sentences with the correct vocab term. When talking about how quickly or slowly a linear function is changing, you are discussing a function's rate of change. The graph of a linear function is a straight line. The line is straight because a linear function has a constant rate of change. When graphing a linear function, slope refers to the steepness of a line the function makes. The slope of the line is the same as the rate of change of the linear function. The slope can be expressed as a decimal, a fraction, or an integer. So in number 8, we have Jasmine is skating. Find the slope / rate from the table and verify that the rate is constant. Find the y-intercept. So when we're doing slope, we want to look at how our distance is changing. So we go from 0.7 to 1.1. If you're not sure, you can always do the bottom number minus the top number. So that's going to get us a change of plus 0.04, which is the same for the next 2 points, 0.04. When we look at how the seconds are changing, these are just increasing by 1. So our slope here is going to be 0.4 divided by 1, which is just 0.4. Because this is a word problem, we have our units. So the distance is going to be feet per, and then the x, the time is per second. The y-intercept. The y-intercept is always when time is 0 or the x value is 0. So here, this is the row that we have 0. So we are going to write it as a coordinate. So we would have 0, comma 0.7. In number 9, we want to find the slope in the y-intercept. So if we look at our change in y from -10 to -5, we are increasing by 5, so plus 5. From -5 to 10, we added 15. And from 10 to 15, we added 5. If we look at the x's, from -10 to -8, we added 2. From -8 to -2, we added 6. And from -2 to 0, we added 2. So in this case, we have two different numbers. We have 5 over 2, which we can't reduce at all. And then we have 15 over 6. We want to make sure it's the same slope. So if I reduce 15 over 6, I can divide both numbers by 3 and I get 5 over 2. So my slope, no matter which set I use, is going to be 5 over 2. My y-intercept, this is where people get confused. Your y-intercept is not where the table starts. It's where the x value has a 0. So 0 is down here. So 0, 15 is going to be our y-intercept. In number 10, after 3 weeks, Cassidy has saved $40, and after 13 weeks, she has saved $160. So each sentence here is going to get an ordered pair. So we have 3, comma 40, and we have 13, comma 160. When we go to find the rate of change, we are comparing the weeks to money. So at 3 weeks, she has $40, and at 13 weeks, she has $160. If we look at our rate of change, from 40 to 160, we added 120, and from 3 to 13, we added 10. So our rate of change is going to be 120 over 10, which is equal to $12 per week. So remember then, when you look at a function rule, the slope is always going to be multiplied with the independent variable, and the y-intercept is going to be the starting point, or what is being added or subtracted. So in number 11, we have to make the function rule first. So Jackie is spending $25 every month. She starts with $156 in her bank account. Y equals money and X equals months. So we have Y equals, she's starting with $156 and she's spending 25 per month. So we're going to do minus 25X. Our slope then is the number that is in front of X. So our slope is -25. Because it's a word problem in this case, we know that she then is spending right? $25 every month, so it's going to be negative $25 per month. The y-intercept is where she is starting at, so this is going to be 0, 156. In B and C, we have function rules. So our slope is going to be the number in front of the variable. So our slope for the first equation is 2, and the second equation is negative 1/2. The y-intercept is the number by itself. So in B, our y-intercept will be 0, negative 15, and in C, our y-intercept would be 0, 12. Find the slope of each graph. Make sure to provide units when appropriate. So in number 12, we're not going to have any units. We're just going to find our slope. So I want to pick 2 points and I make my slope triangle. So I went down 1 and I went over 1, 2, 3, 4 grid line. So it's rise over run. So my slope would be 1/4. In 13, this is a flat line. So anytime we have a flat line, that is going to be a slope of 0. Because this has units, it's the y units per the x units, so it would be miles per hour. In 14, we want to find the slope of the following. So we want to find the slope of line A, B, C, and D. So line A, when I look at my 2 points, I went down from A 1, 2, 3, and I went over 1, 2, 3. So my slope is negative 3 over 3, which is equal to negative 1. Remember to always reduce your fraction. B is a horizontal line, so that's going to be a slope of 0. C, we went up and over. So I went up 1, 2, 3, 4, and I went over 1, 2, 3, 4, 5, 6. So our slope is 4 over 6, which is 2/3. Now, line D is a special type of slope as well. Whenever you have a vertical line, your slope is going to be undefined. What is the y-intercept? So in line A, we are crossing the y-axis at 0, 0. In line B, we are crossing it at 0, 4. In line C, we are crossing at 0, negative 5. And in line D, it never crosses the y-axis, so this is going to be none.